Okay, we're back for our next installment of motor controls, and we have talked about the magnetic motor starter, and we've talked about the control transformer, how it divides the power circuit from the control circuit. But before we move on, I made a little video of a homemade transformer I have. It's real simple, and so just watch this real quick, and gives you a live demonstration and shows you what the mutual induction looks like. You can actually see the mutual induction going on that we talked about. So watch this real quick and we'll come back, okay? All right, guys, this is a little homemade transformer that I have, and it's really, kind of give you a good visual demonstration of what you see inside a transformer. Okay, so first of all, we have the three parts of our transformer. This is a coil, and this is our iron core, and this is our secondary core. This is the primary, and this is the core, and this is our secondary coil. Okay, so this is a spool of wire that just came off the shelf at Home Depot or Lowe's or wherever, and as I said, it's nothing but a big long piece of wire, single piece of wire wrapped around a gazillion times with a beginning and an end. Now I've got it hooked to a power cord right here, so you really can't see it, but there's nothing magic going on inside here. It's just power going to the hot side and coming back to the neutral side, and it plugs into the wall with a standard plug. Okay, and what I'm going to do is when I plug this up, we're going to have, you're going to hear it too, you can really hear this thing hum, but we are going to energize this coil and create a magnetic field. Now, a couple of things are going to happen, one of which you'll be able to see, one of them you won't be able to see. But what's going to happen is that magnetic field is going to be induced into these welding rods. This is nothing but a big stack of welding rods kind of globbed together and taped together to hold them still. And it's going to induce a magnetic field into our iron core, so to speak. Okay, and so we're going to have it in our iron core, and then the magnetic field will then be induced into this secondary. Now there's a couple of principles I want to talk to you about. If you remember correctly from our previous video, you notice that the coils of wire, both the primary and the secondary, are not wired together. I made that statement, and I'm going to show you, obviously you can see it right now, but you'll see how a voltage will be induced into the secondary of our transformer. Okay, so we're going to induce a voltage, and you should see a light. Now, I did not make a very long coil, I did not do a lot of wraps, so our voltage is a little weak getting here. If I had more coils, then it would get brighter, but I just slapped one together real quick, and it lights up enough to where you can see a voltage being induced in here, and the result is a light that starts to illuminate. Okay, and as I take it away from that stronger magnetic field, it will get dimmer and dimmer. The other thing that you cannot see is, and I'll show it to you, I'll just kind of hold it with my hand, is there's going to be heat generated. That's the form of work. Remember we said that whenever you have electron flow that we're converting into some form of work, it creates heat. This is no exception. So without further ado, I'm going to go ahead and plug in the primary coil to my voltage source, 120 volts, going into a wall outlet kind of thing. And you can hear it humming. Now, if you remember, the humming and buzzing that you're hearing is the positive and negative sine wave going, peaking, building, and collapsing, peaking from positive to negative 60 times a second. And it's humming, it's vibrating, I can feel it. Okay, so right now, and I'm feeling the welding rods right here at the base around the bottom of my finger here, starting to feel that base start to get a little warm because the magnetic field lines of flux are going into that welding rod, and that's our form of work. Okay, that's why we don't have a short circuit going on, even though I'm literally plugging the 120 leg to our neutral with what it looks like no load, but this coil of wire is creating a magnetic field, and by inducing it into the iron core, that is the work we're doing. So I'm going to take my secondary coil. Notice I'm not going to wire it to anything. I'm going to take my secondary coil and let that building and collapsing of the magnetic field into the secondary, inducing a voltage. You see it light up. Again, if I had taken a little more time and wrapped maybe twice as many, it'd be brighter. But you can see it is creating a voltage that's giving us the light. And the further I get away from the magnetic field, the dimmer it gets. Now, in an ideal world, this would circle back around in a circle like you saw on the slides in the previous video. It would have a termination. It would kind of go around, but here we're kind of leaving that magnetic field out into the open, so it's not a very efficient transformer at all. But as you can hear it run and see it run, I'm going to kill the power. Okay, and now I'm feeling this too. It's significantly warmer. It's not like what you call hot, but it's significantly warmer. But that transformers, they do heat up. Okay, but anyway, this is just a quick demonstration. I thought it might help give you a visualization of the mutual induction. So again, thanks for watching, and continue to watch the rest of the lecture video. Okay, I hope that cleared things up for you a little bit. Gave you a visual demonstration of the transformer and that mutual induction. So let's keep moving forward in our lesson 4, controls and control systems. Okay, so just very quickly, this is our schematic that we're going to use to kind of demonstrate and drive home both sides of the circuit. Okay. Again, you know the power circuit, you know the high voltage side. We covered transformers, step-down transformers specifically, and in this one we're just going to say that we've got 240 volts of 3-phase supplied. We're using 2 legs of that's still single phase, going to the primary coil of our transformer, wrapping around the core, the iron core, the laminated iron core, and again we have a coil of wire wrapped around the second set of coils there called the secondary, that provides us with the step down lower, safer voltage than the 240. And in this case, we're going to step it down in half, a 2-to-1 ratio, and we're going to have 120 volts coming out at single phase, okay, for our control circuit. So we talked about what we needed, the power, in the last video we needed the power, we needed the control transformer, okay, and now what we've got is some devices that help us control these contacts that start and stop our motor, okay. First of all, there are so many symbols that we could cover. I'm not going to do that because a lot of them you won't use. And again, but when you just go up to it and you get some of these general, most commonly used input devices, you'll kind of get an idea of what they are. But the first one we're going to talk about is the normally closed push button, okay? This is the stop button, all right? It's normally, people will consider this an emergency stop. Hit it and it kills the control circuit. It kills everything that the control circuit is operating. But in this case, it's the normally closed push button. We call it normally closed because without pressing the operator, and the operator is a fancy name for button, okay? So without pressing the button, just holding it right here in its normal position, right off the shelf, okay, you might say, this set of contacts is closed, okay? So power is able to come through these normally closed set of contacts without ever touching a button. Now on the flip side of that is the normally open set of contacts, okay? And this is our start button, a typical start button, okay? And I just happen to have it on the flip side. Here's a stop and a start here, okay? And its normal state, I'm just sitting here holding it, not pressing the operators or anything. In its normal state, these set of contacts are open. So our power can flow through the normally closed on our stop half, and it will come here until we press this button. It's going to hang out right there until we press our start button, okay? And these contacts, both the normally closed and the normally open, I'm going to try to get these in here a little bit for you. You can see that when I press the stop button, these are normally closed, meaning that power will go from here to here just by sitting here holding the switch. And this is the normally open set, that power can be right here, but it will not flow to the other side until I press the operator. You can see the contacts. Here's the two surfaces, and we're trying to bridge these two contacts together, and we have a bar across the top that I'm going to show you a better demonstration a little bit later. But we press that and it bridges these two contacts, okay? Well, right now on the normally closed side, they're bridged together already. So when we press them, we take that bridge between the two contacts and we disrupt that circuit. So that's normally closed, nothing going on with my hand here. And this is normally open, and they will only close when I press the operator. So there's your normally open and normally closed contacts, and a little demonstration of how they work, okay? So these are input devices, and I discussed this in one of the labs. Input devices do not convert any of the electron flow into any form of work. They don't do any kind of work for us other than passing that current through their contacts. That's all they do. They don't convert the electron flow into heat or any type of rotary motion. They don't do any work for us. They just kind of like gatekeepers. They just pass on the information, okay? Pass on the electron flow. So we've got two input devices in our control circuit so far. And then finally, as you learned in the very, very beginning of this class, you've got to have three basic devices in order to have a complete circuit. We have a power source. In this case, it's the secondary of our transformer. We have our conductors. We could skip our input devices, but we have this load that will convert the electron flow into work. Now, this is our load device. It is the contactor or motor starter coil. There's that word again, coil, where we're talking about one piece of wire wrapped around and around and around. We create a magnetic field that's going to attract some piece of laminated steel, okay? So that's what the motor contactor does, is when we energize the coil. Now, I want to be real certain to let you know, in the control circuit, this is not the motor, okay? This is the motor and the motor contactor are separate, okay? The contactor coil here is simply in the control circuit, and we energize that and we create that magnetic field. All right, now I've got one here too. Okay, now this is a magnetic motor starter, and this is the overload block, and I'm going to take these out just for right now for demonstration purposes. Okay, and so here is our motor starter. Now we have our coil that hooks, our wire hooks to the coil right here. Okay, hope you can see that. That's the beginning of that piece of wire that goes around and around in a circle a gazillion times, and it comes out right here, okay? And it makes a loop, and there's a piece of steel, and I'm not going to bother taking this apart, but there's a piece of iron in here that will be drawn into that magnetic field. And when it draws it into that magnetic field, you can see here, here's our normally open contacts right here. These are right here. And this coil is right here. Now, these two are in the same device, but they are not connected in terms of electrically. They are not connected. So when we energize our coil, we create that magnetic field, and I'm going to simulate it here for you, and it pulls those contacts down and closes the gap between this, our supply voltage, and our load voltage going out to our motor. Okay? I'm going to drop this piece here and kind of say it again. Again, we're going to put voltage on our coil right here. Here's our positive, 120 going in, and here's our neutral, 120 going out. That would be through here, okay? So when we energize that coil, we create that magnetic field. Boom, it pulls it, and these little copper bridge pieces right here, these are contacts. These are normally open contacts. Again, these are the contacts right there. So when we close them, we energize it, we close the contacts. The voltage is resting right here, and then when we close it, it gives it a path to exit the starter and on out to the motor. So that's how the motor starter works. But I want to make sure that you understand that this M in this circle is not the motor. That's the coil to the motor starter only. Okay. When we close the contacts, then the motor runs. But these two are not the same. Okay, and they are not connected in any way, shape, or form. Okay. These, however, are. These are the contacts I just showed you in that motor starter. Okay? And then we have a set of overload contacts that we're going to talk about a little bit later, but they are part of the control circuit as well. Okay? So this is the symbol for a coil, whether it's a relay or a motor starter or a contactor. This is the symbol for a coil. Okay? Now, it's not the same symbol as the coil that you're used to seeing for a transformer, completely different, and they're drawn different for that very purpose. So here's the control symbol for control coil, relay coil, or motor starter coil. Okay, and here's a little graphic here, a little file that shows you that when we energize our coil of wire and create that magnetic field, it pulls that armature down and it breaks the normally closed contacts and then closes them on the normally open side. Okay, so again, and when we let the current go, when we shut the current off, the voltage off, then a spring pushes these contacts back up, and I wish I could stop this in motion, but I can't. So we're just energizing, de-energizing, energizing, de-energizing, and all it's doing is pulling that armature down here, and these armatures are connected to a set of contacts, okay? Doing the exact same thing here. We energize that coil, and the armature pulls these three contacts closed, and our voltage goes to our motor. And then when we de-energize it, when we cut the power off to our coil, this a spring separates these contacts, and then our motor and our current stays back here, or our voltage is resting there on the input side of the normally open contacts. Okay. Now we're just going to step through this a little bit more, just to drive it home a little bit more. But that's the general concept. So starting off here, we have three-phase voltage going to each of our contacts, just kind of sitting there hanging out. We're not doing anything with it. That's our potential. Okay. So we have our three phases going here, and we also have two of our three phases going to fire or to energize our primary coil of our transformer. Okay. And whenever that's energized, we automatically and instantly get voltage coming out of our secondary. Okay. So let's go ahead and so we've energized our transformer. We've got power coming out of the transformer, step down lower voltage, and we are going through the normally closed contacts because I'm not pressing that stop button. I'm leaving it alone. It's normally closed, so it's going to allow that current to flow through the contacts, and it's going to come park right here and hang out because we are not pressing the start button. Okay. Once we press the start button, then we'll let it flow. But for right now, it's hanging out at this stop button, and our current going to our motor, our voltage going to our motor, is just hanging out on the input side of our normally open contacts. Now, when we press the start button, and I'm going to apologize ahead of time, I don't have a real good way of making this press down, but if you'll simulate it with me in your head, we'll press down, and then we energize that coil. Okay, that coil creates that magnetic field. That's the work that the circuit's doing, the load is doing. It's creating that magnetic field, and then this goes back to our neutral to complete our circuit. Okay, we're leaving home, we're getting back home, and we are energizing that coil. Now, what's also happening at the exact same time, okay, is these contacts are going to close. So I'm going to run through this again, and then when this energizes, it pulls these contacts closed, and now we have a path of three-phase voltage to our motor. Okay, so we're running along just as happy as clams because we are holding our start button in. If you'll simulate that again with me, our normally open is now closed. Not normally closed, but it's just considered closed. These contacts are closed, and we're allowing current to flow through here. Okay, so the second that I take my finger off the stop button, then we lose the voltage to our coil. Our coil de-energizes, and a spring overtakes and pops these normally open contacts open, and here sits our voltage parked again. Now, the one thing I don't have is, there you go, that's what really should happen. That should be where that's at right now. So I'll just kind of run back through that real quick. We're running along here. We've energized the motor starter coil. It has pulled these contacts closed. We are running our motor, and then we let go of the start button, and all of a sudden the motor, the secondary voltage goes to stops here. We no longer have an energized coil. These contacts pop back open, and our voltage is cut off from our motor, and it's just sitting there waiting on the contacts for the next time for us to push the start button. Okay, and that's how we control the motor with our control circuit. Okay, now there's a little bit more to this that we're going to get into. At this point, I want to stop and just kind of let you absorb that, because it's not convenient to stand there and hold the button. That's less convenient than the manual motor starter. When you press the button, at least it would lock over and stay energized, and you could walk away. This is less convenient, as I've shown you right here, but I always have something better for you, and that's what we're going to get into next. We're going to talk about sealing circuits so that you can press that button and walk away. And probably most of you have these at home, and I'm going to show you where exactly you might find that. But for right now, just absorb this part of the lecture. This is the second part, and we'll go from there. Thanks for watching, and I'll see you back here for the last installment.